Hello and welcome you in the course of Probability and Statistics. I am your instructor Hardik Joshi. Now today we should learn about test of hypothesis. Now the different thing is, what is the different thing in this particular lecture? So test of hypothesis for equality of means of two population. That is, we have to check the whether the two means, that is two different strategy, two different object is given, and we have to check whether equality of means corresponding to that two population is accept या rejects. So let's see in the more detail. So test of hypothesis for equality of means of two populations. Now remember this thing, the population variance are known. In our previous lecture, we have to discuss the testing of hypothesis where the variance is unknown. So corresponding to that, we have to use one particular LJIET statistics which does not involve the variance. But right now, here the population variance are known. So there are a variety of LJIET statistics is available to check the hypothesis. So let's see again. We have to see the procedure corresponding to this hypothesis. The almost each and every major step is same because there is just minor difference corresponding to this particular case. Right now the variance is known, so definitely we have to select the LJIET statistics in such a manner it includes the terms of variance. So let's start the procedure. So step number 1. We have to test the hypothesis for equality of means of two populations. So definitely there are two populations, so corresponding there are two mean. Say mu x, that is corresponding to first data. So we have to consider first population, and the corresponding to the first population the mean is mu x. Also we have to consider second populations because there are two populations. Corresponding to this second population, we have to again consider mean and is denoted by mu1. Now this sigma x square is the variance because right now it defines a variance is 1. That's why we have to include the variance. So this just x is just a notation. Otherwise variance is just only sigma square. But here we have to include the suffix x. Now that represents is corresponding to the first population. Now similarly this sigma y square where the suffix y is introduced corresponding to the second populations. So we have to introduce mean as well as the variance corresponding to first population as well as second population. And right now we have to test the hypothesis whether the equality of means, that is we have to build up the null hypothesis, both the means are equal, that is mu x is equivalent to mu y. And in the against of this null hypothesis, definitely we have to write down the alternative hypothesis. And already we know that at this stage, the alternative hypothesis, it may be considered three cases. First of all, say mu x not equal to mu y, that is two-sided tail. Mu x is greater than mu y, that is one-sided right tail test. Mu x less than mu y, that is one-sided left tail test. So these are the step number 1. So that is just minor change in the test parameter. What is defined or what is unknown. So we have to consider that basic changes in the step number 1. Now step number 2. We have to gather the data to test the hypothesis. So corresponding to two data, we have to consider say sample data from both the population. So let x1, x2 up to xm be a random sample. It may be same observation among the population 1. y1, y2 up to yn be again a random but n observation among the population 2. And definitely m greater equal to 30 and greater equal to 30. That is both the population 1 and population 2 are large sample, and definitely is a population 1 as well as population 2 are different. That's why we have to highlight the term. both the random sample are independent. There is no common sample xi is equal to yi for particular any of the. Now step number 3. Before testing of any of the hypothesis, definitely you have to predefine what is your level of significance, that is alpha. Whether it is 1%, 5%, 10%, or it may be anything. Step number 4. Corresponding to whatever data is given, that is which quantity is known, which quantity is unknown. On the basis of that, we have to consider the Z statistics. So we have to consider Z statistics is equivalent to x bar minus y bar minus mu x upon mu x minus mu y upon sigma x square upon n plus sigma y square upon n, where corresponding to this null hypothesis, where x bar and y bar are our mean, this mu x, these are the observed mean, mu x and mu y is the predefined, that is the mean which is already defined in the definition. Now sigma x square, sigma y square is the variance corresponding to population 1 and population 2. M and N are the number of random sample corresponding to population 1 and population 2. So here we have to consider the fact that the mu x is equivalent to mu y because this is our null hypothesis. Both the population means are same. Now we have to assume this quantity, so this term is vanishing from the numerator. Because mu x is mu y, so this term is 0, so we have to neglect that. So Z statistics is equivalent to x bar minus y bar upon this same denominator, that is sigma x square upon m plus sigma y square upon n. So remember here, it may be not that the Z statistics when sigma x square and sigma y square is also same, that is variance corresponding to first population as well as second population is same. So remember here is a variance square, and if both are same, so definitely we have to take outside from the square root. So sigma is outside, so just only 1 by m plus 1 by n. These are the particular case of this Z statistics when the variance of the first as well as second population is same. Now step number 5. Corresponding to the taken random observation, we have to calculate the value of Z statistic, that is Z observed value, x bar minus y bar upon sigma x square upon n plus sigma y square upon n. Now step number 6. Now according to what level of significance you have to consider, now corresponding to that you have to find out the Z statistics, and now is already predefined, just we have to take this value from the Z statistic table, standard normal table. So it is already predefined. So right now in step number 6, there are not too much tasks, just we have to collect one experimental value. Finally on the step number 7, we have to give our decision. Either the null hypothesis is reject or null hypothesis is not reject. On the basis of this, modulus of Z naught, that is Z observed, is greater equal to Z experimental, irrespective of any of the tests. Either it is two-sided or one-sided tail test. So on the basis of this, we have to give our decision whether the null hypothesis is reject or not reject. So these are the procedure to check this particular Z statistics. So let's start the example for better understanding of this Z statistics. So the question suggests that the performance of student of X, that is 10th standard, in a national level talent search examination. So we have to question suggests that they have to take a data of 10th standard students of any of the particular, say, national level talent search examination. The score secured by randomly selected student from 2 districts. Now D1, D stand for the district, 1 that is first district, D stand for district, 2 that is second district. So D1 and D2 definitely may be 2 different districts, and right now our aim is we have to check whether the two mean corresponding to two populations are same or not. That's why we have to consider two different districts. The number of students randomly selected from the district D1 and district D2 are 500 and 1800. Remember, the students are randomly selected. Now 500 students selected from the district D1, 800 students selected from second district. Now average, that is, again you have to see carefully, the mean is given. Average score secured by the students selected from the first district and second districts are 58 and 57. That is, mu x is 58 and mu y is 57. That is, mu x is a mean corresponding to the first district, mu y, that is mean corresponding to second district. That is, mean is norm. Can the sample be regarded as drawn from the identical population having common standard deviation? Also, standard deviation is given. Standard deviation is 2. Now we have to check, that is, test the hypothesis at the 5% level of significance. Whether the question, whatever null hypothesis we have to predefine, it may be reject or not reject. So let's start the solution. So step number 1, mu x and mu y, that is mean corresponding to district D1 and district D2. Now second statistic parameter, that is standard deviation, is given in the question. So here two things is given, mean is given, mu x, mu y, standard deviation is given. So on the basis of this, we have to predict or develop a null hypothesis. That is, mu x is equivalent to mu y. That is, average score secured by the student from the district D1 and the district D2 are not significantly different. Both are equal. Next, on the against of null hypothesis, we have to assume alternative hypothesis. Say mu x is not equal to mu y. So see carefully, what is our null hypothesis? The average of the both the districts are different, so it doesn't not different, that is, it may be possible, it may be less than, it may be greater than. That's why we have to consider two-sided alternative test. That is, average score secured by the students from two study districts are significantly different. Right now our consult is not whether mu x is greater than mu y, yeah, mu x is less than mu y. Just we have to identify is distinct or not. That's why we have to consider two-sided alternative test. Now step number 2, on the basis of the definition, we have to gather the data. So is predefined the question. From the first district they have to collect 500 students, from the second district they have to collect 800 students. So we have to consider m is 500, n is 800. Now x bar, that is mean corresponding to this first district, is also given in the definition 58. Mean corresponding to this second district is also given in the definition 57. Now these are the important things. Level of significance. How much accuracy you have to require. Sometimes your hypothesis, the results is also depends on this level of significance. If you have to change the level of significance, then your results may be altered, it may be possible. So here level of significance is 5%. Step number 4. Already we have to discuss, we have to consider the Z statistics is equivalent x bar minus y bar, that is mean is predefined, standard deviation is given in the question, 1 upon m plus 1 upon n. So these are the main thing. You have to see carefully the question. Now which of the statistic parameter is predefined, that is given in the question, and which are unknown corresponding, yeah, on the basis of that you have to identify which Z statistics is applicable. Step number 5, we have to calculate this observed Z value. that is Z observed is equal to X bar minus Y bar upon sigma into square root of 1 by m plus 1 by n. So we know that the mean of the first district is 58, mean of second district 57, standard deviation is 2. Now the size of the random sample of first district is 500 and the random sample collected from the second district is 800. So by solving this simple expression, we have to get the observed Z value is 8.77. Now step number 6, critical value. That is, we have to consider the experimental Z value. Now here we have to consider 5% level of significance and also we have to consider two-sided test. So we have to write down the critical value. Yeah, Z experimental value is 1.96. I will repeat again. If you have any query regarding how we can write down this Z value, then I will suggest you have to go through the lecture level of significance. Now finally step number 7, we have to give our decision whether the null hypothesis is reject or not reject. So Z observed value we have to calculate is 8.77 and the Z experimental is 1.96. So definitely 8.7 is definitely greater than 1.96. So this condition is satisfied, that is we have to find out too much evidence against the null hypothesis. That's why we have to say that the null hypothesis, that is H0, is rejected. So more precisely we have to say that it indicates that the given sample contains sufficient evidence to reject the null hypothesis. So in terms interpretation of this example, we have to say that thus it may be decides that the null hypothesis H0 is rejected. Now H0 is rejected, it means that the average performance of students in the district D1 and D2 in national level talent search examination are significantly different, because null hypothesis suggests that is not significantly different, but the null hypothesis is rejected. That's why we have to say that the level of talent search examination of these two different districts are significantly different. So thank you so much for paying your attention